Picture yourself this morning. You cradle a warm mug between your palms. The ceramic holds heat like a gentle embrace. Steam dances upward from the dark surface, curling into invisible spirals that disappear into the cool air around you. This simple moment holds one of the universe's deepest truths. Your coffee cup is teaching you about time itself. Not the time that ticks on clocks or flows through calendars, but the hidden time that flows through everything. The time that decides which direction the universe moves. Feel the warmth spreading from the mug into your hands. This heat is not staying put. It cannot stay put. Like water flowing downhill, thermal energy always moves from hot places to cool places. Always. Without exception. The coffee was once boiling. Nearly 200 degrees of molecular excitement. Now it sits at perhaps 120 degrees. Comfortable for drinking. Perfect for warming your palms. But it will not stop there. Minute by minute, the heat escapes. It flows through the ceramic walls. It rises with the steam. It radiates outward like ripples in a pond. Your coffee is surrendering its warmth to the vast coolness of the world around it. This is entropy at work. Though you might not know this word yet, you feel its presence every day. Entropy is the universe's way of spreading things out. Of making everything more equal. More mixed. More random. Think of it this way. Imagine you have a box of red marbles on one side and blue marbles on the other. If you shake the box, what happens? The colors mix. They spread. They become jumbled together. Red and blue scattered everywhere. You would never shake that box and find all the red marbles perfectly sorted on one side again. Never. This is entropy's rule. Things spread out. They do not spontaneously organize themselves. Your coffee follows this same rule. The heat spreads out. The energy becomes mixed with the cooler air. The organized, concentrated warmth becomes scattered and diluted. But entropy is more than just heat flowing. It touches everything in your life. When you breathe out, your warm breath mixes with the cool air. When you drop a sugar cube into water, it dissolves and disappears. When you open a bottle of perfume, the scent spreads throughout the room. All of these are entropy working. The universe is like a vast cosmic coffee cup. It started incredibly hot. Infinitely organized. All the energy packed into an impossibly small space. Then it began expanding. Cooling. Spreading its energy across ever-growing distances. Just like your coffee. Your morning cup holds the story of everything. Stars burn their fuel and grow dim. Hot planets cool into cold rocks. Even the atoms in your body are constantly moving, vibrating, sharing their energy with the world around them. This is why we age. Why flowers wilt. Why old houses crumble. Why nothing lasts forever in exactly the same form. But here is something beautiful to consider. Entropy is not destruction. It is transformation. It is the universe's way of exploring every possibility. Of trying every combination. Of making sure that energy touches everything, eventually. When your coffee cools, its heat does not disappear. It spreads into the air. It warms the table. It becomes part of the gentle temperature of your kitchen. The energy transforms. It finds new places to exist. This is why time moves in only one direction. You can watch your coffee cool, but you cannot watch it spontaneously reheat. You can see cream swirl into coffee, but you cannot see it unswirl back into separate streams. Time's arrow points toward greater mixing. Greater spreading. Greater entropy. Scientists call this the second law of thermodynamics. But you can simply call it the way things are. The natural flow of existence. The gentle current that carries all change. Your hands are part of this flow too. They absorb heat from the mug. They radiate warmth into the air. Every cell in your body is part of entropy's dance. taking in energy, using it, transforming it, sharing it with the world. Even your thoughts follow entropy's pattern. Ideas spread from mind to mind. Languages change and evolve. Knowledge flows from teacher to student like heat from warm to cool. As you sit with your coffee, you are holding a small piece of the universe's story. The steam that rises carries billions of water molecules, each one moving randomly, each one following its own chaotic path. Yet together they create the gentle, organized spiral you see. This is entropy's paradox. Individual chaos can create collective beauty. Random motion can generate visible patterns. Disorder at the smallest scale can produce the elegant dance of steam rising from your cup. Your coffee will cool completely, eventually. The heat will find its way into the vast reservoir of the world's temperature. But the memory of that warmth will remain. In the comfort it gave you. In the energy it provided your body. In the moment of peace it created. Entropy spreads energy, but it also spreads experiences. The warmth you feel becomes part of you. Part of your day. Part of your story. And somewhere in your body, molecules are dancing. Atoms are vibrating. Energy is flowing from warm places to cool places. The same fundamental process that cools your coffee is keeping you alive. Keeping you warm. Keeping you connected to the endless flow of the universe. As you finish this last sip, notice how the liquid has reached the perfect temperature. Not too hot. Not too cold. Just right for this moment. Entropy has worked its quiet magic, bringing your coffee to this gentle balance. But beyond your kitchen, beyond this peaceful morning moment, countless other processes are unfolding. In every breath you take, billions of tiny molecules are following the same patterns, the same invisible rules that govern your cooling cup. Right now, as you breathe, something extraordinary is happening. Something so small you cannot see it, yet so magnificent it connects you to every living thing that has ever existed on Earth. Take a slow, deep breath. Feel the cool air entering your nose. Notice how it fills your chest. Hold it gently for a moment. Now breathe out, slowly and softly. In that single breath, you have just inhaled 25 trillion molecules. 25 trillion tiny, invisible dancers. Each one spinning. Each one moving. Each one following the ancient choreography of entropy. These molecules are not still. They never rest. Even in the calmest air, they bounce and tumble like popcorn kernels in a hot pan. They collide with each other billions of times each second. They ricochet in random directions. They create a microscopic storm of constant motion. This is what scientists call Brownian motion. Named after a botanist who first noticed pollen grains jiggling in water under his microscope. But he was seeing something far more profound than dancing pollen. He was witnessing the fundamental restlessness of matter itself. Your breath carries oxygen molecules that came from trees, from ocean waves, from the photosynthesis happening in leaves right now. These same molecules have been part of dinosaur breath. They have swirled through ancient atmospheres. They have crossed continents and oceans. Each molecule in your lungs has its own story, its own journey through time and space. When you inhale, your blood cells reach out like tiny hands. They grab oxygen molecules and hold them tight. But this is not a permanent embrace. Soon, your blood will release these molecules to your muscles, to your brain, to every cell that needs them. And then something beautiful happens. Your cells transform these molecules. They combine oxygen with sugar. They create energy for life. They produce water and carbon dioxide as gentle byproducts. This is entropy working inside your body. Energy flowing from organized fuel into scattered heat. From concentrated sugar into dispersed warmth. From order into useful randomness. The carbon dioxide your cells create begins its own journey. It flows through your bloodstream like a river carrying messages. It travels to your lungs. It waits for the moment when you exhale. And when you breathe out, those carbon dioxide molecules escape into the world. They join the atmospheric dance. They spread and mix with billions of other molecules. They become part of the vast, invisible ocean of air that surrounds our planet. But here is something that might surprise you. The air you just breathed out is warmer than the air you breathed in. Your body has heated it. Your internal furnace has shared its energy with these molecules. You have given them more speed, more motion, more kinetic energy. This is why you can see your breath on cold mornings. The warm, moist air from your lungs meets the cool morning air. The water molecules slow down. They cluster together. They form tiny droplets that catch the light like miniature clouds. Your breath is a perfect example of entropy in action. Heat flows from your warm body into the cooler air. Energy spreads from concentrated to scattered. Order transforms into randomness. Every breath you take is part of a vast recycling system. The oxygen you inhale today was exhaled by a plant yesterday. The carbon dioxide you release will be absorbed by a tree tomorrow. Nothing is wasted. Everything continues moving. Everything continues changing. This is the miracle of the carbon cycle. The endless circulation of atoms through living things. Through rocks. Through oceans. Through the atmosphere. Your breath connects you to this ancient cycle. You are both borrowing and contributing to the planetary system of life. Inside your lungs, millions of tiny air sacs called alveoli work like microscopic balloons. They expand and contract with each breath. Their walls are so thin that molecules can pass through them easily. Like soap bubbles that allow air to flow in and out. The surface area of all your alveoli combined would cover a tennis court. Imagine that. A tennis court's worth of surface area tucked neatly inside your chest. All of it dedicated to the gentle exchange of molecules between your body and the world. Each alveolus is surrounded by tiny blood vessels. Capillaries so narrow that blood cells must travel through them in single file. Like cars on a one-lane mountain road. This creates the perfect conditions for molecular exchange. Oxygen molecules dissolve into your blood. Carbon dioxide molecules bubble out. The process happens automatically. Peacefully. Without any conscious effort on your part. Your body knows exactly how to orchestrate this molecular dance. Temperature plays a crucial role in this process. Warmer molecules move faster. They have more kinetic energy. They collide more frequently. They spread more quickly. This is why exercise makes you breathe harder. Your cells are working faster. Creating more heat. Demanding more oxygen. Producing more carbon dioxide. The molecules in your breath follow the same statistical patterns as all matter in the universe. Some move quickly. Some move slowly. Most move at medium speeds. This distribution of speeds is called the Maxwell-Boltzmann distribution. It describes the way energy spreads through any system. But you do not need to remember these scientific names. You only need to remember that your breath is part of something larger. Something that connects all living things. Something that has been happening for billions of years. The nitrogen molecules in your breath are especially faithful travelers. Unlike oxygen and carbon dioxide, nitrogen does not react easily with other substances. It simply comes along for the ride. Entering your lungs. Leaving unchanged. A quiet witness to the more dramatic chemical exchanges happening around it. These nitrogen molecules have been circulating through Earth's atmosphere for millions of years. They might have been breathed by ancient forests. By dinosaurs. By the first humans. They carry no memory of these encounters. But they continue their endless journey through time. Your breathing creates a rhythm that connects you to the pulse of life itself. Inhale. Exhale. In. Out. Like waves on a shore. Like the rise and fall of the tide. Like the gentle heartbeat of the planet. Each breath brings new molecules into your body. Each exhale releases them back to the world. You are not separate from your environment. You are part of it, connected to it through every molecule you breathe. As you settle into the rhythm of your breathing, notice how natural it feels. How automatic. How perfectly your body knows what to do. This is millions of years of evolution at work, creating the ideal conditions for molecular exchange. And while you breathe, other processes are happening in your body. Your heart is beating. Your blood is flowing, carrying those oxygen molecules to every corner of your being, creating new stories of movement and transformation. Place an ice cube in a clear glass. Set it on the table before you. Watch closely. Listen to the silence. You are about to witness one of nature's most elegant demonstrations of entropy. A perfect lesson in how order transforms into freedom. The ice cube sits before you like a tiny crystal palace. Its edges are sharp and defined. Its surfaces are smooth and flat. Every water molecule inside is locked in place, arranged in perfect geometric patterns, held together by invisible forces that create structure, beauty, order. This is what scientists call a crystal lattice. Imagine a three-dimensional dance where every dancer knows exactly where to stand, where to move, how to hold hands with their neighbors. The water molecules in your ice cube are performing this ancient choreography, each one positioned with mathematical precision. But this perfect order cannot last. Room temperature surrounds your ice cube like a warm embrace. The air molecules are moving faster than the frozen water molecules. They carry more energy, more heat. And heat always flows from warm to cool. Always. Watch the surface of the ice cube. Do you see the first tiny drop of water forming? This is the beginning of transformation. The beginning of entropy's gentle work. The heat from the air touches the ice molecules at the surface. It gives them energy, makes them vibrate, makes them wiggle in their crystal positions. At first, they try to stay in formation, like soldiers maintaining their ranks. But the energy keeps coming. The vibrations grow stronger. And then it happens. One water molecule breaks free from its crystalline prison. Then another. Then hundreds. Then thousands. The perfect order begins to dissolve into liquid freedom. This process has a beautiful name. Phase transition. The moment when matter decides to change its fundamental nature. When solid becomes liquid. When structure becomes flow. When order becomes entropy. Feel the air around you. It is full of invisible energy. Molecular motion. Thermal vibration. This energy wants to spread. It wants to share itself with everything it touches. Your ice cube cannot resist this generous offer of warmth. Each water molecule that escapes the crystal lattice takes energy with it. Energy that was once part of the organized structure. Energy that now becomes part of the random motion of liquid water. The process speeds up as more molecules join the dance of freedom. Watch how the sharp edges of the ice cube begin to round. The precise corners soften into curves. The flat surfaces develop gentle undulations. Entropy is an artist. It prefers smooth lines to sharp angles, flowing forms to rigid structures, natural beauty to artificial perfection. The melting happens faster at the edges and corners. These areas have more surface exposed to the warm air, more opportunities for heat to flow in, more chances for molecules to escape. Physics favors the vulnerable parts first. This is why snowflakes melt from their delicate points inward. Why icicles drip from their tips. Why all frozen things surrender their sharp edges first. Entropy finds the weakest places, the most exposed areas, and it works there with gentle persistence. As your ice cube melts, it is teaching you about temperature. Temperature is not a thing. It is a measurement. a way of describing how fast molecules are moving, how much kinetic energy they possess, how eager they are to dance. The ice molecules move slowly. They vibrate in place but cannot travel far. The liquid water molecules move faster. They slide past each other. They flow. They explore. They have more freedom to express their energy. The air molecules around your glass move fastest of all. They zip and dart and collide in three-dimensional space. They carry heat like messengers, delivering energy to anyone who will accept it. Your melting ice cube is very willing to accept. But melting is not destruction. It is transformation. Every water molecule that was part of the ice cube becomes part of the growing puddle. Nothing is lost. Everything continues. The matter changes its form but never disappears. This is conservation of mass. One of nature's fundamental rules. Matter can change, transform, rearrange itself, but the total amount remains constant. Your ice cube does not vanish. It becomes something new while remaining essentially the same. Watch the water level rise in your glass. Each drop represents thousands of molecules that have found new freedom, new ways to move, new possibilities for interaction. The liquid water can flow around obstacles. It can take the shape of its container. It can mix with other liquids. The solid ice could do none of these things. It was locked into one shape, one arrangement, one way of being. Melting has given these molecules options, choices, the ability to explore different configurations. This is entropy's gift. Not chaos, not destruction, but possibility. The chance to try new arrangements, to explore different states, to discover what happens when order relaxes its grip and allows freedom to flourish. The temperature of your melting ice cube remains constant during the phase transition. All the energy going into the ice is being used to break the molecular bonds, to free the trapped molecules, to transform structure into flow. This energy has a name: latent heat, hidden energy that powers transformation. Only when all the ice has melted will the temperature of the water begin to rise. Only then will the molecules start moving even faster, dancing even more freely, carrying even more thermal energy. Listen carefully. Do you hear tiny sounds coming from your melting ice cube? Little cracks and pops and whispers? These are the sounds of molecular bonds breaking, of crystal structures surrendering, of order giving way to entropy's patient influence. Each sound represents thousands of liberation moments. Water molecules breaking free from their frozen formations, joining the growing community of liquid dancers, adding their voices to the molecular conversation happening in your glass. The process cannot be reversed without outside help. Your puddle of water will not spontaneously freeze back into a perfect ice cube. Not at room temperature. Not without removing energy from the system. This is entropy's direction. From order to flow. From structure to freedom. But this direction is not sad. It is not loss. It is the natural way of things. The universe's preference for exploration over rigidity. For possibility over constraint. For the gentle democracy of molecular motion over the strict monarchy of crystal structure. Your melting ice cube connects you to processes happening everywhere. Glacier flowing into oceans. Snow becoming streams. Frozen ground thawing into fertile soil. All of these are examples of phase transitions. Of entropy working its patient magic. Even inside your own body, similar processes are constantly occurring. Proteins folding and unfolding. Membranes changing their flexibility. Chemical bonds forming and breaking. All following the same fundamental principles you see in your simple glass of melting ice. The last piece of ice grows smaller. Its edges soften further. Its crystal perfection dissolves into liquid possibility. Soon it will be gone completely. transformed into something that can flow. Something that can adapt. Something that can respond to gravity's gentle call. And when that final transformation occurs, you will witness something beautiful. The way liquid water finds its own level. The way it settles into perfect stillness. The way it reflects light like a mirror, creating a surface so smooth it seems almost solid again. Place your hand gently on your chest. Feel that steady rhythm beneath your palm. This is more than just a heartbeat. This is time itself, pulsing through your body. Each beat marks a moment that can never come again. Each pulse pushes your story forward into an uncertain future. Your heart beats roughly 100,000 times each day. 100,000 tiny explosions of muscle and momentum. 100,000 pushes that send blood racing through 60,000 miles of vessels inside you. An entire highway system of circulation, all powered by this faithful drummer in your chest. But your heartbeat is not just keeping you alive. It is creating entropy. It is marking the irreversible flow of time through your body. Each beat transforms organized chemical energy into scattered heat. Each pulse spreads warmth from concentrated places to cooler regions. Each contraction pushes your personal universe a little further from perfect order. Think of your heart as a tiny pump. No different from the pumps that move water through irrigation systems, or oil through pipelines, or air through ventilation systems. But this pump is special. This pump runs on the chemical energy stored in sugar molecules. And it never stops. Never rests. Never takes a break. When your heart contracts, it squeezes like a firm handshake. The pressure builds inside the left ventricle. Higher and higher until it overcomes the resistance of your arteries. Then the heart muscle relaxes. Blood rushes out through the aortic valve. The great journey begins. This is systole. The moment of contraction. The moment when potential energy becomes kinetic energy. When stored pressure becomes flowing movement. When your heart's chemical fuel transforms into the mechanical work of circulation. And then comes diastole. The moment of relaxation. When your heart muscle releases. When the chambers fill again with returning blood. When the cycle prepares to repeat. Like a tide that never stops coming in and going out. Each heartbeat creates a pulse wave that travels through your arteries faster than the blood itself. Like a message running ahead of the main group. This wave carries information about pressure. About timing. About the rhythm of your existence. You can feel it in your wrist. In your neck. In your temple. The blood that leaves your heart carries more than just oxygen and nutrients. It carries heat. Body temperature. The thermal energy generated by your muscles. By your organs. By the countless chemical reactions happening inside every cell. This warm blood flows through your arteries like rivers carrying spring melt from mountain peaks. It branches into smaller and smaller vessels. Arterioles. Then capillaries so thin that red blood cells must travel single file. Like cars on a narrow mountain road. In these tiny capillaries, the real work happens. Oxygen molecules jump from red blood cells into hungry tissues. Carbon dioxide waste products leap back into the bloodstream. Nutrients dissolve across cell membranes. Heat spreads from warmer areas to cooler ones. This is entropy in action. The spreading of energy. The mixing of substances. The transformation of order into useful randomness. Your circulation system is a vast network for distributing entropy throughout your body. The blood that returns to your heart through your veins carries a different story. It moves more slowly. It carries less oxygen. More carbon dioxide. More waste products. More heat from the metabolic fires burning in your tissues. This returning blood is darker. More purple than red. It has given up its brightness to fuel your existence. But it has gained something else. Experience. The molecular memory of having nourished every part of you. Your heart does not care about this difference. It welcomes back the returning blood like a parent welcoming children home from school. It sends this venous blood to your lungs, where the cycle of renewal begins again, where carbon dioxide escapes, where fresh oxygen dissolves, where dark blood becomes bright again. But the energy that powered this entire circulation cannot be recovered. The chemical bonds broken in your heart muscle cannot be reassembled. The heat generated by friction in your blood vessels cannot be gathered back up. This is entropy's law. Energy flows in one direction only. From organized to scattered. From concentrated to dispersed. Your heartbeat marks this irreversible flow of energy through time. Each beat pushes your metabolism forward. Each pulse moves you further from the moment when you were born. Each contraction brings you closer to the moment when this faithful drummer will finally rest. This is not sad. This is the nature of all living things. We are temporary whirlpools of organization in entropy's flowing river. We maintain our structure by constantly processing energy, by transforming fuel into motion, by creating ordered complexity out of simple raw materials. Your heart knows this truth without thinking about it. It beats steadily, reliably, approximately once every second for your entire life. It adapts to your needs. Faster when you exercise, slower when you sleep, but always present, always working, always marking time. The electrical signals that coordinate your heartbeat follow the same principles as all nerve impulses. They depend on the movement of charged particles across cell membranes. Sodium and potassium ions flowing like tiny lightning bolts through your cardiac muscle. These electrical waves spread across your heart in perfect coordination. They ensure that the chambers contract in the right sequence, at the right time, with the right force, like a symphony orchestra following the conductor's baton. But even this electrical system obeys entropy's rules. The energy that creates each heartbeat must come from somewhere. It comes from ATP molecules, the universal energy currency of life. When these molecules break apart, they release the power that makes your heart contract. And like all energy transformations, this process is not perfectly efficient. Some energy becomes heat. Some becomes sound. Some radiates away as the gentle electromagnetic field that doctors can measure with an electrocardiogram machine. Your heartbeat connects you to the rhythms of the universe itself, to the pulsing of distant stars, to the oscillation of atoms, to the cyclic processes that drive everything from weather patterns to planetary orbits. As you feel your pulse beneath your fingers, you are touching one of the fundamental truths of existence. That time moves forward. That energy flows from order to chaos. That life is a beautiful, temporary rebellion against entropy's patient pull toward equilibrium. And beyond the rhythmic drumming in your chest, other processes are stirring. Stars burning in distant galaxies. Planets cooling in the vacuum of space. The entire universe slowly, gently, inexorably spreading its energy across the vast distances between worlds. Look up at the night sky. See those gentle pinpricks of light scattered across the darkness? Each one is a star. Each one is a nuclear furnace burning with the heat of creation itself. Each one is part of the universe's long, slow journey toward coolness, toward stillness, toward the final piece of thermal equilibrium. But it was not always this way. Once, everything was hot. Everything was bright. Everything was squeezed together into a space smaller than the period at the end of this sentence. 13.8 billion years ago, the universe began with what we call the Big Bang. But it was not really a bang. There was no explosion. No sound. No place for sound to travel. Instead, space itself suddenly began expanding. Stretching. Growing larger and larger and larger. In that first moment, the temperature was unimaginable. Trillions of degrees. So hot that matter could not even exist as we know it. so hot that the very particles that make up atoms were too energetic to stay together. Everything was pure energy, pure heat, pure potential. This was the universe at its most organized. All of its energy packed into the tiniest possible space. Maximum concentration, maximum temperature, maximum order. And from that moment forward, entropy began its patient work. As space expanded, the universe began to cool. Like a balloon being inflated, but instead of air, it contained all the energy that would ever exist. As the balloon grew larger, the energy spread out, became more dilute, became cooler. This cooling process continues today. Right now, as you breathe, the universe is still expanding, still stretching, still carrying heat away from concentrated places toward the vast emptiness between galaxies. The cosmic microwave background radiation tells us this story. It is the faint afterglow of that original heat, the last whisper of creation's fire. We can detect it with radio telescopes. We can measure its temperature, about 2.7 degrees above absolute zero, the universe's current body temperature. But the stars you see tonight are fighting against this cooling. They are pockets of rebellion against entropy's steady march toward equilibrium. Each star is a place where gravity has pulled matter back together, where hydrogen nuclei slam into each other with such force that they fuse, where mass transforms into energy, where concentrated fuel burns bright against the cosmic darkness. Your sun is one of these stellar rebels. Every second, it converts 4 million tons of matter into pure energy. The heat and light that warm your face, that make plants grow, that drive the weather patterns on Earth. All of this comes from hydrogen nuclei fusing into helium deep inside the solar core. This process is called nuclear fusion. It is the reverse of the expansion that began the universe. Instead of spreading apart, particles come together. Instead of cooling, they create heat. Instead of entropy, they create concentrated energy. But even fusion cannot last forever. Stars are not perpetual motion machines. They burn through their fuel like candles burning wax. Slowly but inevitably. The hydrogen in your sun's core will eventually run out. The fusion reactions will slow down. The light will dim. This is happening throughout the universe. Stars are being born from collapsing gas clouds. They burn for millions or billions of years. Then they die. They explode as supernovas or fade into white dwarfs or collapse into black holes. Each stellar death releases energy into space, where it spreads, where it cools, where it joins entropy's cosmic circulation. The largest stars burn the brightest but die the youngest. Like sprint runners who exhaust themselves quickly. The smallest stars burn dimly but can last for trillions of years. Like marathon runners pacing themselves for the long journey ahead. But all stars will eventually exhaust their fuel. All nuclear fires will eventually burn out. This is the fate that awaits every source of concentrated energy in the universe. The second law of thermodynamics applies even to stellar furnaces. As stars die, they leave behind remnants. White dwarf stars that cool slowly over cosmic time. Neutron stars that spin like cosmic lighthouses. Black holes that trap light itself. Each of these remnants represents energy that has been transformed, scattered, spread into the growing darkness. Meanwhile, space itself continues expanding. The galaxies move further and further apart, like raisins in rising bread dough. The distances between stars increase. The universe becomes more sparse, more empty, more cold. This expansion carries a beautiful name. The Hubble expansion. Named after the astronomer who first discovered that distant galaxies are moving away from us. The further away they are, the faster they recede. Like the surface of a balloon being inflated from the inside. But this expansion is not just moving matter apart. It is also stretching the wavelengths of light itself. making photons redder, lower in energy, cooler. This is called cosmological redshift. It is another way that the universe spreads its energy across larger and larger volumes. Dark energy accelerates this expansion, a mysterious force that we do not yet fully understand. It seems to be pushing space itself apart, making the universe expand faster and faster, ensuring that the cooling process will continue indefinitely. As billions of years pass, the night sky will change. Stars will burn out faster than new ones are born. Galaxies will drift so far apart that their light will no longer reach us. The cosmic microwave background radiation will stretch to longer and longer wavelengths. The universe will grow darker, colder, quieter. This process has a name: heat death. Not death as we usually think of it, but the death of temperature differences. The end of hot and cold. The moment when all energy has spread evenly throughout space. When entropy reaches its maximum value. At that distant time, no more work can be done. No more engines can run. No more life can exist. The universe will be like a vast ocean with no waves, no currents, no temperature differences to drive the processes that create complexity. But this fate lies trillions of years in the future. Longer than humans have existed. Longer than our sun will shine. Longer than our galaxy will maintain its current form. From our perspective, it is essentially forever. For now, we live in a universe rich with temperature differences, with energy gradients, with the fuel that powers stars and planets and life itself. We exist during the universe's middle age, when there is still enough concentrated energy to create interesting things, complex things, beautiful things. The heat flowing from your body into the cool night air connects you to this cosmic story. Your warmth is part of the universe's energy, temporarily organized into the pattern that is you, eventually destined to spread back into the vast thermal reservoir of space. Your breath carries molecules that were once part of ancient stars. The calcium in your bones was forged in stellar cores. The iron in your blood was created in supernova explosions. You are made from the ashes of cosmic fires, from energy that has been transforming and flowing for billions of years. Every candle flame is a tiny model of stellar fusion. Every melting ice cube demonstrates the same principles that govern galactic evolution. Every heartbeat echoes the rhythm of cosmic expansion and contraction. As you settle into the quiet of evening, you can feel yourself as part of this grand cooling. Part of entropy's patient work. Part of the universe's long journey from concentrated energy toward distributed peace. And while the cosmos slowly spreads its warmth across the growing emptiness of space, closer to home, in the intricate architecture of your own mind, other stories of organization and entropy are unfolding. Close your eyes and remember your first day of school. Can you see the classroom? The teacher's face? The color of your backpack? Notice how some details shine clearly while others have faded to gentle shadows. This is entropy working in your mind. Time's patient erosion sculpting the landscape of your memories. Your brain is not a computer hard drive. It does not store perfect copies of experiences. Instead, it builds memories like coral reefs. Layer by layer. Connection by connection. Each recollection adds something new while wearing away something old. Every memory lives as a pattern of neural connections. Synapses linking one brain cell to another. Chemical bridges spanning tiny gaps between neurons. When you remember something, electrical signals dance across these bridges. They recreate a shadow of the original experience. But each time you recall a memory, you change it slightly. Like telling a story that evolves with each telling. Your current mood colors the past. Your present knowledge fills in missing details. Your brain updates the memory file, then saves this new version over the old one. This is not a flaw in your memory system. This is entropy being creative. Taking organized information and allowing it to mix with new experiences. To adapt. To grow. To become something richer and more connected to your current self. Think of your brain as containing 100 billion neurons. Each one connects to thousands of others. This creates trillions of possible pathways for information to travel. More connections than there are stars in the observable universe. A neural network of almost infinite complexity. Yet this vast network operates on surprisingly simple principles. Neurons either fire or they do not. They send signals or they remain quiet. Like binary switches in a cosmic computer. But from these simple on-off decisions emerges the rich complexity of human consciousness. Your memories are not stored in single locations. They are distributed patterns. Scattered across multiple brain regions like puzzle pieces hidden throughout a house. Visual details in your visual cortex. Emotional content in your limbic system. Sounds in your auditory areas. Words in your language centers. When you remember something, your brain reassembles these scattered pieces. It reconstructs the memory from its distributed components. Like musicians in different rooms coming together to play a symphony. Sometimes the performance is note perfect. Sometimes instruments are missing. Sometimes new melodies creep in. Sleep plays a crucial role in memory formation. During the quiet hours when you rest, your brain sorts through the day's experiences. It decides what to keep and what to discard. Important information gets transferred from temporary storage to more permanent networks. Trivial details fade away like footprints on a beach. This process follows entropy's preferences. Frequently used memories become stronger. Their neural pathways become more established. Like hiking trails that grow clearer with repeated use. Rarely accessed memories weaken. Their connections atrophy. Their details blur and merge with similar experiences. Your brain constantly battles against information decay. It strengthens important memories through repetition. Through emotional significance. Through connection to existing knowledge. But it cannot preserve everything with perfect clarity. Entropy ensures that some information will always be lost. Forgetting is not the opposite of remembering. Forgetting is an active process. Your brain deliberately lets go of unnecessary information. It clears out mental clutter to make room for new experiences. This selective forgetting is essential for mental health. For creativity. For the ability to focus on what matters most. Consider how you remember faces. Your brain does not store photographic images. Instead, it extracts key features. The distance between the eyes. The shape of the nose. The curve of the smile. It creates a simplified map that captures the essence of recognition while discarding countless minor details. This compression allows you to recognize someone even when they change hairstyles. Even when they age. Even when lighting conditions are different. Your memory system trades perfect accuracy for flexible usefulness. This is entropy working as an editor. Keeping what matters. Letting go of what does not. Your childhood memories demonstrate entropy's long-term effects most clearly. The sharp edges of early experiences have softened. Colors have faded to pastels. Conversations have been reduced to their emotional essence. What remains is not a documentary record but an impressionist painting of your past. Yet these faded memories often carry more meaning than recent experiences. They have been refined by time. Polished by repeated recollection. The essential truths have survived while surface details have been worn away. Like river stone smoothed by decades of flowing water. Language itself shapes how you remember. Words provide frameworks for organizing experiences. Categories for sorting information. But language is imperfect. It cannot capture every nuance of lived experience. Each time you put a memory into words, something is gained but something is also lost. Dreams offer a window into memory's entropy. During sleep, your brain processes information in loosely connected ways. Logical sequences break apart. Cause and effect become fluid. Past and present merge. This is not random chaos but a different kind of order. A creative disorder that allows new connections to form. Your memories of dreams fade especially quickly upon waking. Like morning mist dissolving in sunlight. The dream state uses different neural chemistry than waking consciousness. The memories formed during dreams are encoded weakly. They succumb to entropy's pull more readily than daytime experiences. Even your most vivid memories are reconstructions rather than playbacks. Your brain fills in missing details with educated guesses. It smooths over gaps with plausible information. It creates coherent narratives from fragmented data. This is why eyewitness testimony can be unreliable. Not because people lie, but because memory itself is a creative act. The phenomenon of false memories reveals entropy's creative power. Sometimes your brain constructs entire experiences that never happened. These false memories can feel completely real. They activate the same neural networks as genuine memories. They demonstrate that your mind is not a passive recorder but an active creator of meaning. As you age, the balance between memory formation and decay shifts subtly. New memories may take longer to form strong connections. Older memories may become more fragile. But wisdom often grows during this process. The ability to see patterns across decades of experience. To extract meaning from the accumulated erosion of time. Your memory is not fighting against entropy. It is dancing with it. Using time's patient erosion as a sculptor uses weathering. To reveal the essential forms hidden within the raw stone of experience. To create something beautiful from the inevitable process of forgetting. And even as your memories fade and transform, your brain continues its quiet work of maintenance and renewal. Repairing damaged connections. Building new pathways. Creating the mechanical foundations that support all thought and feeling. Imagine a master clockmaker sitting at his workbench. His hands move with practiced precision. He files each gear to perfection. He polishes every surface until it gleams. He dreams of creating a clock that will run forever. A perpetual motion machine that needs no winding. No maintenance. No outside energy. But this clockmaker faces an impossible challenge. One that has defeated every engineer who has ever lived. He is fighting against friction. Against entropy. Against the fundamental laws of physics themselves. Every gear in his clock touches another gear. Metal against metal. As the teeth mesh together, they rub. They scrape. They generate heat. This friction steals energy from the clock's motion. It transforms the organized energy of spinning wheels into the random energy of molecular vibration. The clockmaker can reduce friction but never eliminate it completely. He can use the finest oils, the smoothest bearings, the most precisely machined parts. But even the most perfect surfaces are rough at the atomic level. Like mountain ranges viewed through a powerful microscope. When atoms on one surface slide past atoms on another surface, they tug at each other. They stick and slip in microscopic ways. These tiny interactions add up to create resistance. Heat. The gradual slowing of all mechanical motion. This is why your bicycle chain needs oil. Why car engines need lubrication. Why even the most advanced machines eventually wear down. Friction is entropy's agent in the mechanical world. It ensures that no machine can run forever without fresh energy. The energy lost to friction does not disappear. It cannot disappear. The law of conservation of energy forbids it. Instead, this energy transforms. From the organized motion of gears and wheels into the random motion of warm molecules. From mechanical work into thermal energy. You can feel this transformation happening. Rub your hands together quickly. Feel the warmth building between your palms. This heat comes from the friction between your skin surfaces. The mechanical energy of your muscles has become thermal energy. Molecular motion. Entropy. Every machine ever built has faced this same fate. Steam engines lose energy to friction in their pistons. Wind turbines lose energy in their spinning bearings. Even computer hard drives lose energy as their disks spin against air resistance. The clockmaker's dream of perpetual motion violates what scientists call the second law of thermodynamics. This law states that in any closed system, entropy always increases. Energy always flows from organized forms to disorganized forms, from useful motion to waste heat. But machines are not completely defeated by friction. They are transformed by it. A clock that stops running has not lost its energy. That energy has become part of the thermal motion of its parts, part of the ambient temperature of the room, part of entropy's vast collection of scattered energy. Consider a wind-up toy car racing across the floor. At first, it moves quickly. The spring inside is tightly coiled, full of potential energy. As the car rolls forward, this potential energy becomes kinetic energy, the energy of motion. But with each turn of the wheels, friction takes its toll. The gears inside the toy heat up slightly. The axles warm from bearing friction. Air resistance slows the car's forward progress. Gradually, all the organized energy stored in the spring spreads into random molecular motion. The car eventually stops. But the total energy remains the same. It has simply changed forms. From concentrated spring tension to scattered heat. From ordered motion to disordered thermal vibration. This transformation happens in every mechanical system. From grandfather clocks to jet engines. From playground swings to planetary rotations. All mechanical motion eventually succumbs to friction's patient erosion. Yet this apparent defeat contains hidden beauty. Friction is not just destruction. It is transformation. It allows mechanical systems to find equilibrium, to settle into states of minimum energy, to achieve the peaceful stillness that entropy prefers. Watch a spinning coin gradually slow down and fall flat on the table. Friction with the air and the table surface removes energy from its rotation. The coin's motion becomes simpler, more stable, less chaotic. It finds its natural resting state. This is entropy working as a peacemaker, taking complex, energetic motion and gradually simplifying it, reducing it to thermal equilibrium, to the quiet democracy of molecular motion where no single direction of movement dominates. The clockmaker learns to work with friction rather than against it. He designs escapement mechanisms that regulate the release of energy, that control the flow of power from spring to gears, that turn friction into a tool for timekeeping rather than an enemy of precision. In fact, many machines depend on friction to function properly. Car brakes use friction to convert kinetic energy into heat. Guitar strings use friction with air to create sound waves. Even walking depends on friction between your shoes and the ground. Without friction, you could not stop once you started moving. Wheels would spin uselessly without gripping the road. Tools would slip from your hands. The organized world of solid objects would become a realm of frictionless chaos. This reveals friction's dual nature. It destroys perpetual motion but enables controlled motion. It prevents perfect efficiency but allows practical functionality. It transforms energy but does not waste it. The thermal energy created by friction joins the vast reservoir of heat energy in the universe. It becomes part of the random molecular motion that maintains temperature, that drives weather patterns, that powers the thermal engines of living things. Even the heat generated by friction in machines serves useful purposes. It can warm buildings in winter, power steam engines, drive thermoelectric generators. What seems like waste becomes resource when viewed from entropy's perspective. Modern engineers understand the clockmaker's dilemma. They design machines that work with entropy rather than against it. They use friction deliberately. They harness thermal energy. They create systems that transform energy efficiently while accepting that perfect efficiency is impossible. Electric motors convert electrical energy into mechanical motion with remarkable efficiency. But even the best motors lose some energy to resistance in their wires, to friction in their bearings. to heat generation in their magnetic fields. This is not failure. This is physics. The clockmaker's impossible dream teaches us something profound about the nature of reality. Perfect order cannot be maintained without constant input of energy. Perfect machines cannot exist in our imperfect universe. But imperfect machines can accomplish extraordinary things. Your own body faces the same challenges as the clockmaker's mechanisms. Your joints experience friction. Your muscles generate heat. Your cells transform chemical energy into mechanical work with less than perfect efficiency. Yet this apparent imperfection enables the miracle of life. Like the wise clockmaker who learns to embrace friction as part of his craft, living systems use entropy as a creative force. They harness the flow of energy from order to disorder. They ride entropy's current like skilled sailors navigating cosmic winds. The heat from your body warms the air around you. Your breath carries thermal energy into the atmosphere. Your footsteps leave traces of warmth on the ground below. You are part of the same energy transformation that powers clockwork and steam engines. And beyond the mechanical world of gears and springs, water moves through an even grander system of energy transformation, flowing always toward the lowest places, carrying the stories of mountains and clouds. Listen to the sound of rain against your window. Each drop is a tiny messenger in the universe's most beautiful story of entropy. Water falling from clouds, gathering into streams, flowing toward the sea, following gravity's gentle command toward the lowest possible place. But this is not a story of simple descent. This is a story of cycles within cycles, of entropy creating order even as it spreads energy across the landscape, of the sun's warmth lifting countless molecules skyward, only to have them fall again as rain. Every raindrop begins its journey in the vast blue cathedral of the ocean. There, water molecules dance with thermal energy. They vibrate and tumble in liquid freedom. Some move fast enough to break free from their liquid bonds, to leap into the air as invisible vapor, to begin their pilgrimage skyward. This process is called evaporation. It requires energy. Heat from the sun provides this energy. Solar radiation strikes the ocean surface. It gives water molecules the kinetic energy they need to escape, to transform from liquid to gas, to join the invisible river of moisture flowing through the atmosphere. As these water molecules rise, they carry energy with them. The latent heat of vaporization. This is energy temporarily hidden inside the molecular structure of water vapor, like potential energy stored in a compressed spring, waiting to be released. The warm, moist air rises higher into the atmosphere. As it climbs, it expands. It cools. The water vapor molecules slow down. They lose kinetic energy. They begin to cluster together around tiny particles of dust and salt, forming the microscopic droplets that become clouds. This is condensation, the reverse of evaporation. The moment when the latent heat stored in water vapor releases back into the atmosphere. This released energy warms the air. It powers weather systems. It drives the great circulation patterns that distribute heat around the planet. Watch clouds forming on a summer afternoon. See how they build upward like castles in the sky. This vertical growth is powered by condensation, by the energy released when water vapor transforms back into liquid droplets. Each cloud is a visible demonstration of entropy working as an architect. The droplets inside clouds are incredibly small, so tiny that air currents can hold them suspended. They float like microscopic balloons in the atmospheric ocean. But gravity never stops pulling. Eventually, some droplets grow large enough to fall, to begin their descent as rain. Each raindrop that hits the ground carries a story written in hydrogen and oxygen. It may have evaporated from a tropical ocean months ago, traveled thousands of miles as water vapor, condensed in a distant cloud, fallen as snow on a mountain peak, melted in spring sunshine, joined a stream, flowed through rivers. Now it falls again, adding its tiny mass to the vast network of water flowing across continents, following the paths carved by countless generations of raindrops before it. Seeking the lowest elevation, the most direct route back to the sea. This is entropy expressing itself through hydraulics. Water always flows downhill, always seeks equilibrium, always spreads from high places to low places. Like heat flowing from warm objects to cool ones. Like gases expanding to fill available space. But the sun's energy constantly works against this gravitational pull. It lifts water molecules back into the atmosphere. It powers the hydrological cycle that keeps water circulating between ocean and sky, between vapor and liquid, between high places and low places. This creates what scientists call a steady state. A dynamic equilibrium where the rate of evaporation equals the rate of precipitation over long time periods. Water continuously cycles through different phases and locations while the total amount remains constant. Rivers demonstrate entropy's artistic sensibilities. They carve graceful curves through landscapes. They create meanders that loop back on themselves. They build deltas where sediment spreads into fan-shaped patterns, all following the mathematical principles that govern flowing systems. The Mississippi River Delta looks like a branching tree when viewed from space. Each distributary channel seeks its own path to the sea. The pattern resembles blood vessels, or lightning, or the neural networks in your brain. These are all examples of entropy creating similar structures in different contexts. As rivers flow toward the ocean, they carry more than just water. They transport dissolved minerals, tiny particles of soil and rock, nutrients from decaying plants. All of this material gets mixed and distributed, spread across vast distances, shared between ecosystems. This is entropy working as a great mixer, taking concentrated materials from one location and dispersing them across the landscape, creating the chemical diversity that supports life, building the soil that feeds forests, delivering the nutrients that nourish coastal wetlands. When rivers finally reach the sea, they surrender their identity to the vast oceanic reservoir. Fresh water mixes with salt water. River temperatures blend with ocean temperatures. The organized flow of the river disperses into the random motion of oceanic currents. But even the ocean is not perfectly mixed. Different temperatures create layers. Different salt concentrations create boundaries. Ocean currents carry warm water toward polar regions. Cold water flows toward tropical areas. The ocean becomes a giant heat engine powered by solar energy and planetary rotation. Deep ocean currents move like incredibly slow rivers beneath the surface. They carry nutrients from the depths to surface waters. They transport heat from equatorial regions toward the poles. They complete circulation patterns that take centuries to complete full cycles. These currents follow entropy's principles on a planetary scale. They distribute heat energy. They mix chemical concentrations. They spread life-supporting nutrients across oceanic distances. They create the conditions that make Earth habitable for complex life. Evaporation from the ocean's surface removes pure water but leaves salt behind. Over geological time, this process has concentrated minerals in seawater. The ocean has become a vast solution of dissolved chemicals, a global reservoir of elements that life depends upon. Some of this salt water gets trapped in isolated basins, salt lakes, inland seas. Here, evaporation continues without fresh water input. The concentration of dissolved minerals increases. Eventually, the water becomes so salty that it can hold no more dissolved material. Salt crystals begin to precipitate out of solution. This is how nature creates salt deposits. How ancient seas become underground mineral formations. How entropy transforms liquid solutions into solid crystals through the simple process of evaporation and concentration. The water cycle connects every living thing on Earth. The moisture in your breath once fell as rain on distant mountains. The water in your cells once flowed through ancient rivers. The humidity in your room once evaporated from tropical oceans. You are part of this vast circulation system. When you sweat, you contribute water vapor to the atmosphere. When you drink, you participate in the movement of water through ecosystems. Your body is a temporary stopping point in water's endless journey between earth and sky. The rain outside your window will eventually return to the sea. But not before flowing through streams and rivers. Not before nourishing plants and animals. Not before participating in the countless small dramas of the water cycle. And in the far future, when this planet's story nears its end, the last drops of water will still be cycling between vapor and liquid, following the same patient rhythms that have sustained life for billions of years. Imagine a time so far in the future that our sun has long since cooled to darkness. Earth has vanished into cosmic dust. The galaxies have drifted so far apart that each one floats alone in an ocean of empty space. In this distant epoch, only the smallest, most frugal stars still shine. These are the red dwarf stars. The universe's most patient residents. They burn their hydrogen fuel so slowly, so carefully, that they can shine for trillions of years. Long after our sun and all the brilliant giants have exhausted their nuclear fires, these gentle embers continue their quiet work. But even the red dwarfs cannot burn forever. Even these masters of conservation must eventually surrender to entropy's patient accounting. In the far future's quiet theater, the last star will dim to ember glow. Its light will be the universe's final warm whisper before darkness claims its ancient throne. This last star will not die dramatically. There will be no supernova explosion. No violent collapse into a black hole. Instead, it will simply fade. Like a candle burning down to its final moments. Like a campfire settling into glowing coals. As its hydrogen fuel dwindles, the star's nuclear reactions will slow. The fierce dance of fusion that has sustained it for countless eons will begin to falter. Fewer and fewer hydrogen nuclei will collide with enough energy to merge. The star's internal furnace will cool degree by degree. Without the outward pressure of nuclear fusion, gravity will begin to win its ancient struggle. The star will contract slowly. Its outer layers will settle inward like a gentle sigh. The compression will heat the remaining fuel briefly, causing the star to flare one last time. But this final flare is not a resurrection. It is a farewell. The star's remaining hydrogen burns quickly in this compressed state. Soon, even this last fuel is exhausted. The nuclear fires go out forever. The star becomes a white dwarf. A hot, dense ember slowly cooling in the cosmic darkness. This white dwarf will be incredibly small but incredibly hot. All the mass of the original star compressed into a sphere no larger than Earth. Its surface will glow white hot for millions of years. Then yellow. Then red. Then infrared. Slowly radiating its remaining heat into the empty space around it. This cooling process follows the same principles that govern your morning coffee. Heat flows from hot objects to cold surroundings. Always. The white dwarf's thermal energy spreads outward in all directions. It joins the cosmic microwave background radiation. It becomes part of the universe's slowly equalizing temperature. As the white dwarf cools, it will pass through a spectrum of colors. Like a piece of heated metal cooling in a blacksmith's shop. White to yellow to orange to red to deep crimson. Each color represents a lower temperature. Less thermal energy. Fewer high-energy photons escaping into space. Eventually, after billions more years, the white dwarf will cool to the temperature of its surroundings. It will become a black dwarf. A cold, dark sphere of compressed matter floating invisibly through space. Still there, but no longer shining. No longer contributing light to the universe's fading illumination. This will be the fate of every star. The massive ones will explode as supernovas and leave behind neutron stars or black holes. The medium-sized ones like our sun will shed their outer layers and become white dwarfs. The tiny red dwarfs will simply fade away. But all will eventually stop shining. When the last star dies, the universe will enter what astronomers call the degenerate era. No more nuclear fusion will occur anywhere. No more starlight will illuminate the cosmic darkness. The only remaining sources of energy will be the slow decay of massive particles and the gradual evaporation of black holes. Black holes, those mysterious regions where gravity has triumphed completely, will become the universe's final energy sources. Through a process called Hawking radiation, they will slowly evaporate, giving up their mass as energy, returning their captured matter to the universe as photons and elementary particles. But even this process follows entropy's rules. Large black holes evaporate more slowly than small ones. The supermassive black holes at the centers of galaxies will take an unimaginably long time to disappear. Longer than the current age of the universe multiplied by itself countless times. As these last black holes evaporate, they will release their energy into a universe that has grown incredibly cold and sparse. The cosmos will be filled mostly with empty space and elementary particles moving at nearly the speed of light. Photons carrying the last whispers of energy across vast, dark distances. This era will be called the photon era. The universe will be illuminated only by the faint glow of evaporating black holes and the cosmic microwave background radiation, stretched by cosmic expansion to incredibly long wavelengths. Colder than anything we can imagine today. Yet even in this seemingly desolate future, entropy will not have finished its work. Protons themselves, the building blocks of atomic nuclei, may eventually decay. If they do, even the cold, dark remnants of stars will slowly dissolve into elementary particles and energy. This process would take an almost incomprehensible amount of time. A number so large that writing it out would require more zeros than there are atoms in the observable universe today. But entropy is patient. It has all the time in the universe. Literally. If protons decay, the universe will eventually reach maximum entropy. Every form of organized matter will have dissolved. Every temperature difference will have equalized. Every energy gradient will have flattened. The cosmos will achieve perfect thermal equilibrium. In this final state, sometimes called the heat death, no more work can be performed. No more engines can run. No more complex structures can form or maintain themselves. The universe will be like a vast ocean with no waves, no currents, no temperature differences to drive any kind of change. But this ending is not destruction in the way we usually think of it. It is transformation. The atoms that once formed stars and planets and living things will not disappear. They will continue existing as individual particles in a sea of perfect equality. Their bonds broken. Their organizations dissolved. But their essence preserved. The energy that once powered stellar fusion and planetary rotation and human thoughts will still exist too. Spread evenly throughout space as thermal motion. As the random vibrations of particles in perfect equilibrium. As the final democratic distribution of the universe's finite energy budget. This vision of the far future might seem sad from our perspective. We are accustomed to stars and galaxies. To structure and complexity. To the beautiful imperfections that make life possible. The idea of perfect equilibrium feels empty to us. But from entropy's perspective, this final state represents ultimate peace. The end of struggle. The resolution of all tensions. The moment when the universe finally achieves the perfect balance it has been seeking since the moment of its birth. And perhaps, in that distant future, new forms of order might emerge. Quantum fluctuations might create temporary islands of complexity in the sea of equilibrium. Random events might organize themselves into patterns we cannot yet imagine. But for now, in our current cosmic epoch, stars still shine in the darkness. Galaxies still spiral through space. Life still creates temporary rebellions against entropy's patient pull toward simplicity. We exist during the universe's youth, when energy gradients still power the processes that create beauty and complexity. Yet even here, in our star-filled present, the principles that will govern the last star's gentle goodbye are already at work, quietly shaping every process that sustains the intricate dance of existence. You are an impossibility. A walking, breathing contradiction to entropy's patient pull toward simplicity. While the universe spreads energy from concentrated places to scattered places, you gather simple molecules and build them into intricate patterns. You create order from chaos. You swim upstream against the cosmic current. This is life's greatest mystery and most beautiful rebellion. How does a collection of carbon, hydrogen, oxygen, and nitrogen atoms organize itself into something that thinks, that feels, that dreams of stars and writes poetry about entropy itself? The answer lies not in defying physics but in using physics creatively. Life does not break the laws of thermodynamics. Instead, it exploits them. It finds ways to decrease local entropy by increasing entropy elsewhere. It creates islands of organization in an ocean of randomness. Think of your body as a temporary whirlpool in entropy's flowing river. The water in a whirlpool appears to defy the river's downstream current. It spins in circles. It maintains its shape against the flow. But it accomplishes this only by directing the river's energy through its spinning pattern. Your cells work in similar ways. They take in simple molecules from your environment. Sugar molecules, amino acids, fatty acids. These are entropy's raw materials. Relatively simple, relatively disorganized. But your cellular machinery transforms them into proteins, into DNA, into the complex molecular architecture of life. This transformation requires energy. Lots of energy. Your cells burn sugar molecules like tiny campfires. They break chemical bonds that were formed when plants captured sunlight. They release the stored energy and use it to power the chemical reactions that build and maintain your body. But here is the crucial point. Your cells produce more entropy than they consume. For every molecule of organized protein they construct, they generate heat. They create waste products. They increase the total disorder in your environment even as they decrease the disorder within themselves. This is how life obeys the second law of thermodynamics while appearing to violate it. The total entropy of the system always increases. But life redistributes that entropy. It concentrates order in living things by creating more disorder in the surrounding environment. Your metabolism demonstrates this principle beautifully. When you eat food, you are consuming molecules that plants organized using solar energy. Your digestive system breaks these organized molecules back down into simpler components. It extracts their stored energy and uses it to power your life processes. The waste heat from this process radiates from your body into the cooler air around you. Your breath carries away carbon dioxide and water vapor. Your kidneys filter out chemical byproducts. All of this represents entropy being exported from your organized body into the disorganized environment. Meanwhile, your cells use the extracted energy to perform millions of organized tasks. They repair damaged proteins. They copy DNA with remarkable precision. They transport materials where they are needed. They maintain the delicate chemical balance that keeps you alive. This constant activity requires constant energy input. If you stopped eating, your cells could not maintain their organization. Entropy would begin to win. Your body temperature would drift toward room temperature. Your complex molecular structures would begin to break down. This is why all living things must eat. Why plants need sunlight. Why bacteria need chemical fuel. Why ecosystems need constant energy flow from external sources. Life maintains its rebellious complexity only through continuous energy consumption. But life's rebellion goes beyond individual organisms. Ecosystems create patterns of organization that span entire landscapes. Food webs connect different species in intricate networks. Nutrient cycles move chemical elements through chains of living and non-living components. Consider a forest. Trees capture solar energy through photosynthesis. They use this energy to build complex organic molecules from simple carbon dioxide and water. Animals eat the plants and redistribute the organic molecules through their own metabolic processes. Decomposer organisms break down dead material and return nutrients to the soil. This creates a complex, self-organizing system. The forest maintains its structure not despite entropy but because of entropy. The flow of energy through the ecosystem drives the organization. Like water flowing through a mill wheel, creating organized motion from chaotic flow. Evolution itself demonstrates life's creative relationship with entropy. Random mutations create variation. Most of these changes are harmful and disappear. But occasionally, a random change creates an advantage. A more efficient enzyme. A better sensory system. A more effective survival strategy. Natural selection preserves these advantageous changes. Over time, this process creates increasing complexity. Simple single-celled organisms evolve into multicellular creatures. Basic sensory systems develop into sophisticated nervous systems. Random molecular interactions give rise to consciousness itself. Yet evolution never violates thermodynamic principles. Each step in the process requires energy. Each increase in biological complexity is paid for by increased entropy production. The sun provides the ultimate energy source that powers the entire evolutionary process. Your brain exemplifies life's most remarkable achievement in creating order from disorder. 100 billion neurons connected by trillions of synapses. This creates a network more complex than any computer humans have built. Yet it operates on the same power as a dim light bulb. Your thoughts emerge from patterns of electrical activity flowing through this neural network. Memories form through changes in synaptic connections. Consciousness arises from the coordinated activity of billions of individual cells. Order emerging from apparent chaos. But your brain, like all living systems, maintains its organization only through constant energy consumption. It uses about 20% of your body's total energy budget. It generates heat as a byproduct of its neural activity. It follows the same thermodynamic principles as every other part of your rebellious existence. Life's rebellion is temporary but magnificent. Every living thing is a brief experiment in creating complexity. A momentary eddy in entropy's flowing current. A temporary gathering of matter and energy into patterns that can reproduce, adapt, and even contemplate their own existence. When individual organisms die, their organized structures dissolve back into simpler components. Their complex molecules break down into basic building blocks. Their stored energy returns to the environment as heat. Entropy claims its due from every rebellious life form. But life as a whole continues its upstream swim. New organisms replace old ones. Evolution creates new forms of complexity. The rebellion persists even as individual rebels fall. Life finds new ways to organize matter and energy into patterns of increasing sophistication. This is perhaps life's greatest gift to the universe. It creates meaning from randomness, beauty from chaos, purpose from purposelessness. It writes poetry with proteins. It composes symphonies with DNA. It builds cathedrals from carbon and calcium and dreams. And in the end, when the universe reaches its final state of maximum entropy, life's rebellion will have created something that pure physics could never achieve alone, the experience of being. The knowledge of existence. The appreciation of beauty in a cosmos that might otherwise pass unnoticed through its long journey toward perfect equilibrium. Imagine a vast lake on the stillest possible morning. No wind disturbs its surface. No streams flow into it. No currents move beneath. The water lies perfectly flat, reflecting the sky like an infinite mirror. Every molecule moves randomly, but the overall surface remains unchanged. This is a glimpse of what maximum entropy looks like. In the far distant future, the entire universe will resemble this perfectly still lake. Every particle will move randomly. Every temperature will be the same everywhere. Every pressure will be equal. Every chemical potential will be balanced. Nothing will flow from one place to another because there will be no difference between places. This is not death as we usually imagine it. This is peace. The deepest, most complete peace possible. The universe will have finally solved all its tensions, resolved all its conflicts, found perfect equilibrium in every corner of space and time. The journey toward this state began 13.8 billion years ago with the Big Bang. In that first moment, all energy was concentrated in an impossibly small space. Maximum order. Maximum potential for change. Maximum distance from equilibrium. Since then, entropy has been working patiently to spread that energy across ever larger volumes of space. To cool the hot places. To warm the cold places. To mix the unmixed. To balance the unbalanced. Every process in the universe has contributed to this gradual journey toward maximum entropy. Your morning coffee cooling to room temperature was part of this process. Your breath mixing with the atmosphere was part of this process. Your heartbeat distributing thermal energy through your body was part of this process. Every star burning its fuel into scattered heat was part of this process. At maximum entropy, no more coffee will cool because there will be no temperature differences to drive heat flow. No more breath will mix because everything will already be perfectly mixed. No more hearts will beat because there will be no energy gradients to power biological processes. This might sound tragic from our current perspective. We are creatures of difference and flow. We depend on temperature gradients and chemical imbalances. We thrive in a universe that is far from equilibrium. The idea of perfect balance feels like emptiness to us. But consider how peaceful that final state will be. No more struggling against entropy's current. No more fighting to maintain organization against the pull of disorder. No more effort required to preserve structure or complexity. The universe will have achieved what it has been seeking since the moment of creation. In this state of maximum entropy, time will lose much of its meaning. Without differences to drive change, without gradients to create flow, without imbalances to resolve, the universe will settle into a kind of eternal now. Particles will continue moving, but their motion will be perfectly random. No pattern will emerge that could measure the passage of time. Yet this randomness will contain all possibilities equally. Every possible arrangement of particles will be equally likely. Every conceivable state will occur given enough time. The universe will explore every configuration, every pattern, every structure that physics allows. This exploration will happen infinitely slowly by our current standards. But time itself will have a different character in that far future. Without biological clocks or stellar cycles or chemical reactions to mark its passage, duration will become a purely abstract concept. Quantum mechanics suggests that even in this state of maximum entropy, fluctuations will occur. Random variations in the positions and energies of particles. Most of these fluctuations will be tiny and brief. But occasionally, purely by chance, larger patterns might emerge. These quantum fluctuations could theoretically create temporary islands of order in the sea of equilibrium. Brief moments when particles happen to align in organized ways. Fleeting structures that last for microscopic fractions of a second before dissolving back into randomness. Some physicists speculate that these rare fluctuations might eventually create structures as complex as galaxies, or stars, or even living systems. The probability would be unimaginably small, but in the infinite time available at maximum entropy, even the impossible becomes inevitable. This suggests that maximum entropy might not be an ending but a new kind of beginning. A state where the universe plays with every possible form of organization. Where chance creates temporary experiments in complexity before entropy dissolves them back into the democratic equality of random motion. But these speculations lie in a future so distant that they feel more like poetry than physics. Numbers so large that they dwarf our ability to comprehend them. Timescales that make the current age of the universe seem like a single heartbeat. For now, we exist in the universe's youth. In an epoch of stars and galaxies and temperature differences. In a time when entropy drives the processes that create beauty and complexity and consciousness. We are temporary patterns in entropy's flow, but what magnificent patterns we are. Our existence proves that entropy is not just a force of destruction. It is also a force of creation. The same processes that will eventually lead to maximum entropy also power the engines of life. The same energy flow that cools stars also warms living bodies. The same mixing that will eventually homogenize the universe also creates the chemical diversity that makes complexity possible. This is perhaps the most profound insight of our journey through entropy's domain. The universe is not running down toward a meaningless end. It is exploring every possibility. It is discovering what it means to exist. It is creating temporary islands of awareness that can appreciate their own improbable beauty. You are one of those islands. A brief eddy in entropy's flowing stream. A momentary gathering of matter and energy into a pattern that can think and feel and wonder about its place in the cosmic story. And as you settle into the quiet rhythms of sleep, you become part of entropy's gentle work. Your breathing slows. Your heartbeat quiets. Your body temperature drops slightly as you release the day's accumulated heat into the cooler air around you. This nightly surrender to rest mirrors the universe's own patient journey toward its final peaceful equilibrium, where all motion becomes the gentle democracy of thermal vibration, and all complexity dissolves into the infinite patience of maximum entropy, waiting forever in perfect, undisturbed stillness.